Hi everyone, this is lesson 3.3.1, and in this lesson we're going to be looking at converting between exponential and logarithmic forms. Example 1.
Alright, hi everybody. This question here is asking us to evaluate the following logarithms without a calculator, and then we can use one later on to verify the solution, but for what we're going to do right now, we won't even really require the calculator. So what we're going to do here, first of all, we're going to zoom in on these questions here so you can see them a little bit more clearly. The first one we're going to look at here is the log, and let's just take a look at that. That is the log of 100,000. Okay? Now, remember when the base of the logarithm isn't written, this is base 10. So now, there are a couple of ways you can look at this that make this still fairly easy to solve here. But one way to do this is to just reduce this to a power of 10. So this is going to become the log, remember that's base 10 if the base isn't written, 10 to the what? Well, 10 to the 5. Okay, there are 1, 2, 3, 4, 5 zeros, so it's 10 to the 5. Now, you can see this a couple of different ways. There is a rule about this. If you've got log of 10 to the 5 here, this is going to be 5. Okay, but you could also think about it if you wanted to bring down the 5, bring down the exponent. This is log base 10 of 10. And log base 10 of 10 is just 1, so either way it's going to be 5. Now let's take a quick look over here. Log base 2 of 16. Well, very similar to the one that we just did. The issue here is about writing the argument here in terms of the same base. This is base 2, so we want to write 16 as a base of 2. So the log base 2 of, and 16 is 2 to the 4. And so now the rule tells us that that has to be 4. Okay, log base 2 of 2 to the 4 has got to be 4. Now, there's another law in there, law of logarithms. If you've seen this already, that would state that we can bring down the exponent, make this the log base 2 of 2, and the log base 2 of 2 is just 1. And again, that would just be equal to 4. Over in this next one here, the log base 9 of the square root of 9. Again, we want to write that argument as a power of 9. So this will be log base 9 of 9 to the 1/2. Okay, because the two bases here are the same of the logarithm of another power, I know that this is just going to be to the 1/2. Or I could think about this as bringing down the exponent, okay, because that's one of my rules there. This becomes the log base 9 of 9. And I know that that's just equal to 1, and so my answer becomes 1/2.
Example 2.
All right. Now this question is asking us to convert the following to exponential form. Now granted, there are a handful of them here. There are 9 of them, but we're going to do these kind of all at once here and talk about them all together here. Convert the following to exponential form. This is an important skill in this chapter here, to be able to see how we move from one form to another. And this will have a direct bearing on your ability to solve the equations here. So, and I guess just because I've said that, I'll state it like this. When we're solving logarithmic equations, one of the things you want to be able to do is get it to this form where it's a logarithm equals some value, and then convert it to the exponential form, basically to get rid of the logarithm here. Now, when we convert this to exponential form, remember that the base is going to be the same. So the base of the log will be the same as the base of the corresponding power. So it's going to be the base 3. And a logarithm is equal to an exponent, so this has to be 3 to the v will equal the argument of the logarithm, w. And there it is. That's as easy as it is. Now there's all sorts of rules. There's little things that you can use to help you memorize this, and I know that, and your teacher will probably go through that with you. But I really want you to understand the structure of this. The base of the logarithm is the base of the corresponding power, and the logarithm is an exponent. So that v goes in the exponent. So let's take a quick look at b. Okay, this is just written in the reverse form here. Okay, the base of the logarithm is the base of the corresponding power. A logarithm is an exponent, so this becomes 7 cubed is equal to the argument x. Now we could evaluate what 7 cubed is, but that's okay. The issue right now is just converting it to the other form. Let's try it again. Now in this case here, this one's not quite so straightforward, because this isn't just a straightforward logarithm here. This is 3 log base b of 4. So there's a coefficient in front of the logarithm, and we actually want to get rid of that first. And there will be a couple of different ways to do this. So I'm going to kind of split this up into 2 different possibilities here. One possibility, and this is the one that I would normally think to do, because that's just the way my head works about this, is I would divide both sides by 3. to make this, 2/3 is equal to the log base b of 4. Okay? So I get the logarithm isolated, and then I convert. The base of the logarithm has got to be the same as the base of the corresponding power, and a logarithm is an exponent. So it would be b to the 2/3 is equal to the argument of the logarithm, 4. That's one way of doing it. Now, if you're familiar with the laws of logarithms, okay, if that's comfortable for you right now, another thing we could do is take that coefficient up as an exponent in the argument of the logarithm. So this becomes 2 is equal to the log base b of 4 cubed. Oops, make sure that that looks clear. 4 cubed. And that's okay as well. So now, to convert forms, we take the base of the logarithm. That's got to be the same as the base of the corresponding power. So this will be b squared, b to the 2, because a logarithm is an exponent. And that will now equal the argument of the logarithm. So b squared is equal to 4 cubed. And just taking a quick look at this, if I was to take the cube root of both sides to isolate the 4, I would get b to the 2/3. These are exactly the same. Okay, and again, I could go through and evaluate this and solve for b, but that's not the point right now. The point is converting forms. So let's keep trying. Let's keep practicing here. Okay, log base h of 8 is equal to 3/2. Now, this question is quite honestly designed to throw you off a little bit. Given the question that we just did, you might be tempted to want to move something around here, but that's actually not necessary. What we want to do here is we actually want to leave it like this because the logarithm is already isolated. So the exponent there, what's on the other side here, that will be my exponent here. So the base is the same. So the base of the logarithm becomes the base of the exponential. The logarithm is equal to an exponent, so this will be h to the 3/2, and that will equal 8. Okay? Down here, don't let the fact that there's something going on in the argument of the logarithm right now throw you off. It's not important right now, because right now what's important is that the logarithm is isolated, okay, equal to this value here. So the base of the logarithm is the same. Oops, sorry, I wrote a b. I meant 6. 6 to the w, okay, because a logarithm is an exponent, and that will equal the argument of the original logarithm. Okay, good. Down here, again, don't worry about what's going on in the argument of the logarithm. You can deal with that later if you even need to. It might not even be necessary for you to do anything about it here. But the logarithm is isolated, so the base of the logarithm will be the same as the base of the corresponding exponential. The logarithm is an exponent, so this will be 2 cubed is equal to r over 4. I mean, if you really need to, okay, maybe what I'll do is at the end here, what I'll do is I'll run through and I'll evaluate some of these things that seem fairly clear here. But for right now, that's all we needed to do. Okay, g, log base 2 of d over 5 is equal to -2. Now, I know that there's some issues with negatives and logarithms, okay? However, a logarithm can be negative. It's just we're not allowing you at this point in this course to take the logarithm of a negative. In other words, the negative can't be inside, but it can certainly be outside here. So there's not a problem with this, converting this to exponential form. The base is 2, so the base of the corresponding exponential will be 2. So 2 to the -2 will equal the argument of the logarithm, so d over 5. Okay, and again, that's all we have to do. And I will come back in just a couple seconds here, and we'll start to evaluate some stuff. But for right now, just convert. Okay, 9 log base 3 of w is equal to v. Okay, well, let's get that logarithm isolated. So the first thing I want to do, okay, is either divide both sides by 9. So this could be log base 3 of w is equal to v over 9, or what I could do, remember, is I could take that 9 up and make this the log base 3 of w to the 9 is equal to v. They're both the same. Okay, doesn't matter which of these I do, I work through, they're going to give me the same result here. So now the logarithm is isolated. The base of the logarithm is the base of the exponential power, and a logarithm is an exponent, so this will be 3 to the v over 9 is equal to w. Or over here, the base of the logarithm is the same, so 3. 3 to the v is equal to w to the 9. Either one of those is good. And now finally in this little section right here, We've got this logarithm, again, that needs to be isolated here. It's the coefficient of 1/3 out front. So again, I can do a couple of things, but I think the easiest thing to do would certainly be to multiply both sides by 3 to make this 12 is equal to the log base 2 of x. Now, I think that's the easiest, but that's not necessarily true. Some of you might still see this as bringing the 1/3 up. So this could be 4 is equal to the log base 2 of x to the 1/3. That's fine. That's totally fine. And now we'll convert forms here. So this will become 2 to the 12. Okay, because the base of the logarithm is the base of the power. A logarithm is equal to an exponent, so 2 to the 12 is equal to x. Or you could think of this as 2 to the 4. Base of the logarithm is the base of the power. Logarithm is an exponent, and this will equal x to the 1/3, the argument of the logarithm. Okay. Now, if you really did feel the need to go back and evaluate some of these, let's go do this now here. Let's take a quick look. Okay, A. There was really nothing we could do with A. A is fine. But now here, if you really wanted to, because it didn't feel right because we left it like this, 7 cubed is 343, and that would be equal to the value of x there. Okay. For C, okay, if b to the 2/3 is equal to 4, then, or you can even do it like this, b squared is equal to the 4 cubed. What we might do here, this might be the easier one to work with even. We might take the square root of both sides, so b is equal to the 4 to the 3/2. Okay. Whoops. I don't know what that was. You take the square root of 4 is 2, cubed is 8, so b is equal to 8. Okay, if that's what you want. We'll go up here to D. H to the 3/2 is equal to 8, which means h is equal to 8 to the 2/3. You raise both sides to the reciprocal power. The cube root of 8 is 2, squared is 4. There's my h. Over here, this one here, it's really hard to know what to do. I don't really know what you want to isolate for here. I mean, we could, if you really wanted to get v by itself, that would be 6 to the w over 7, but you really don't gain a whole lot by doing that. So, but anyway, that's something you could do. This one here, I might multiply both sides by 4 to bring that up out of here, and 2 cubed is 8, so 8 times 4, well, that tells us that r would be equal to 32. H, oops. Oh, sorry, I know it's not. H, G, got to go up to G here. Okay, well, I could multiply both sides by 5, and then 2 to the negative 2. That's going to bring that down to the denominator. So this will be 5 over 2 squared, or 4, and that would be D. Okay. H. Wow, there's really not much I can do with H. That's about as simple as they're going to get, either one of those. So that's probably pretty good. Here. 2 to the 12 is equal to x, or this one right here, well, this one's probably easier to work with, and 2 to the 12 is just going to be 4,096. And so there's your value of x. Not that that was necessary in this problem, but I know for some people that little bit of closure really does help.
Example 3.
All right, this question is very similar to the previous one. Convert the following into logarithmic form. So here what we're doing is we're doing the exact opposite to what we did in the previous one, which was convert to exponential form. We're going to go backwards here. So, but the rule stays the same here. Notice in this case here, the base of the exponential function is x, which means the base of the logarithmic function will be x. And a logarithm is an exponent, so that means this is going to equal 7y. And so what we're left with here is what's on the other side of the equal sign. That becomes the argument of the logarithm. Now, the only other thing that we might do here, and it's not part of the question specifically here, but we might want to just divide by 7 here, okay, so that we get the y isolated. Now, next question here. Y equals 2 times 6 to the x. Now, you got to understand here that in order for us to make a comparison between this exponential function and its corresponding logarithmic function, I need to have the exponential function isolated. I need to bring that 2 over. So this basically needs to become y over 2 first is equal to 6 to the x. Now I've got a very clear idea of what that exponential function is. I know that the base of the corresponding logarithm has to be 6. And then I know that this is going to equal y over, this is going to, equal y over 2. Okay. Oh, sorry, I'm sorry. What am I doing here? I'm sorry, that's just crazy talk. I'm looking back and forth at another resource here, and I saw the wrong thing. It's got to be x. Sorry, because the base of the logarithm is the same as the base of the exponential, and a logarithm is the exponent. So this is going to be the log of y over 2 is equal to x, that exponent there. Now, this question right here, C, don't let the fact that we've got binomials here and a binomial here, okay, don't let that throw you off. When we convert this, notice that the exponential is isolated here. And when we convert this to the logarithmic form, the rules are still the same here. The base of the logarithm is the same as the base of the exponential function. A logarithm is equal to an exponent, so this is going to equal x minus 15. And then it's the argument of the logarithm is what the exponential function is equal to. So this is the log base 2 of y plus 1 is equal to x minus 15. Now, in terms of solving for the variable, we might move the 15 over. I mean, if we really felt we needed to, we might write this as the log base 2 of y plus 1 plus 15 equals x, but I don't know that that's absolutely necessary. Next, y equals 4 to the x minus 13. Similar to one that we did previously, what we got to do here first is isolate the exponential part of this. So we got to bring that 13 over. Got to make this y plus 13 is equal to 4 to the x. And now to convert this to the logarithmic form here, the base is the same. So this will be the log base 4. The logarithm is equal to the exponent. So this is going to be the log base 4 is going to equal x. And then it's going to be the log base 4 of y plus 13. Okay, the other side of the equation, whatever the exponential function is equal to, that becomes the argument of the logarithm. And there we go. Over here, question E. Okay, here's our exponential function here, and notice that it is already isolated. Don't let the fact that there's the two factors over here, don't let that throw you off. Okay, the exponential function is what we need isolated here. And so this becomes the log base 42, because the base of the exponential becomes the base of the logarithm. A logarithm is equal to the exponent, so it'll be the log base 42 of y. Sorry, is equal to y here, but it's going to be the log base 42 of 6x is equal to y. And now, finally here, f. Okay, x is equal to 5 halves, 14 to the y. First thing that we got to do, we got to get that exponential function isolated. So I'm going to multiply by 2, divide by 5. So 2/5 of x is going to equal 14 to the y. My logarithm is going to be log base 14 because the exponential function has a base of 14. It's going to equal y because my logarithm is the exponent. The exponent here is y. And then again, what's on the other side of the exponential function? That is the argument of the logarithm. So log base 14 of 2/5 x is equal to y. And there we go.
Example 4.
All right, let's take a quick look at this question here. If log base 3 of x is equal to 21, then find the value of log base 3 of 1/9 of x. Okay, well, you know what? There's a couple of things that we can do here, but this question really does seem to be, well, okay. There are a couple ways to do this. I tell you what, I'm going to do this in two different ways. I'm kind of rethinking how I'm going to approach this here. One way to think about this is I'm giving you some information right up front here about x. So let's pull that information out here. So what I might do with this to get the x out here is I might convert this to my exponential form. So this would be 3 to the 21 is equal to x. Okay. So just by converting this first logarithm to exponential form, I get a little bit of information about x. Now what I can do is when it says find the value of log base 3 of 1/9 of x, well, what I might do here now is state this, that if this is true, then therefore the log base 3 of 1/9 x is going to be the log base 3 of 1/9 of 3 to the 21. Now, I notice from here, 9 is also a base 3, power base 3. So this is going to be the log base 3 of, well, this will be 1 over 3 squared times 3 to the 21. Okay. So what I'm going to do here, now I'll move this over because I'm going to lose the other piece. Well, that's going to equal the log base 3. This is going to be, now notice that 3 squared is in the denominator. This is 3 to the 21 is in the numerator. Okay, so I'm taking 3 to the 21. I am dividing by 3 squared, which means this will be 3 to the 21 minus 2. Okay, remember that kind of division becomes subtraction. And so this is now equal to the log base 3 of 3 to the 19. And we should have seen at this point here, one of the rules, if you've got log base 3 of a power of 3, well, those are inverses of each other, and so the result is going to be that that's going to equal 19. Now, that is one way of doing it. Okay, that is one way of doing it. Another way of doing it is if we go back to our original question right here, another way of thinking about this is that I'm telling you that the log base 3 of x is 21. Now, what if I come over here and take a look at this bit right here? Now, you may or may not have been at a point here where you've explored all of the logarithm laws here. It's hard to tell where people are going to be at. But one of the things I can do here is I'm going to take this log base 3 of 1/9 x, and I'm going to rewrite that. I'm going to make this the log base 3 of x over 9. And I hope nobody's thrown off by that. 1/9 of x is really just the same as x divided by 9. And now because I've got division there, this is going to be written as log base 3 of x minus the log base 3 of 9. Okay? Now, what's important here is that I was told originally in the problem that the log base 3 of x is equal to 21. So I know that this bit right here is actually equal to 21. Okay, a little bit of experience with logarithms tells me that the log base 3 of 9, well, that's just going to be 2. And then 21 minus 2 is just 19. So either way I see to approach this, I'm going to get 19 as the final answer for this question.
Example 5.
Okay, this question here is very similar to the one that we just did. That says here, if log of the common log of 3 is a, and the common log of 7 is b, then find the common log of 27 over 49 in terms of a and b. Oops, in terms of a and b. Now, okay, I'll do this the same one in two different ways, just like I did the previous one here. This is telling me that if I rewrite this, if I convert this to my exponential form, this tells me that 10 to the a, because the base here is 10, and the a, because it's what a logarithm is equal to, that's going to be my exponent. So 10 to the a is going to equal 3. Here, by the same logic, 10 to the 7, sorry, it's 10 to the 7, sorry, 10 to the b is equal to 7. Okay, remember the base of the logarithm is base of the power, and then the logarithm is the exponent, so there it goes. Okay, so 10 to the b is equal to 7. Now, what I'm going to do here is I'm going to take a look at the log of 27 over 49. Well, okay, the log of 27 over 49, well, I just got to think about this a little bit here. 27 is going to be 3 cubed, and 49 will be 7 squared. Now, I need the 3 and the 7 to pop out because over here, this is what I've got my power set equal to. So now I've got 3 cubed, 7 squared. What I can now do is rewrite those bases in terms of these new powers that I've got. So instead of 3 cubed, okay, this will be 10 to the a cubed. And instead of 7 squared, I'll make this 10 to the b squared. All right? So just a substitution for 3 and 7 based on the information that I was given at the beginning of this problem here. Well, now I've got inside this logarithm, I've got powers here that could now be simplified. So this is going to end up being, okay, the common log, I should point that out, I'm using common logs the whole way up here. This is just going to be 10 to the 3a divided by 10 to the 2b. And because I'm dividing powers here, I know that I can just subtract exponents. So this will be the common log of 10 to the 3a minus 2b. Okay? And, okay, sorry, I see a mistake that I made in a little bit of my notes here. And now, I know that I've got the log base 10 of a power of 10. This will end up being 3a minus 2b. Whoops, there you go, just off the screen there. Now, that's one way of doing it. Okay, another way of doing it is to go back up here and recognize I've got the common log of 3 is a, the common log of 7 is equal to b. What I can do is I can actually start to tear this thing apart, okay, in terms of the log laws. Now, again, depending on where you're at in the course, you may or may not be familiar with these, and it doesn't really matter. There is, like I said, the previous way I approached this. But when I see division in here, okay, division becomes subtraction between logs. And then I would look at this and I would say, okay, well 27, okay, that is going to be the log of 3 cubed, and 49 is the log of 7 squared. And now, because of the laws of exponents, I know that I can bring down the 3, so this will become 3 common log of 3 minus 2 common log of 7. And then it's just substitution, because originally in the problem, I was told that the log of 3 was equal to a, so this will be 3a. And then the log of 7 is equal to b, so this will end up being 2b. So no matter how I approach this, I'm going to get 3a minus 2b. The only issue that I have here doing it this way is you got to be careful. It's sometimes tempting to stop here and say, okay, well this is just a to the 3 and this is b squared. But please bear in mind here, what's being cubed here? In this case, it's the 3 being cubed, not the log of 3. Okay? A was equivalent to the log of 3. And at this point here, that cubed does not go to that here, just like the same thing here. It's the 7 being squared here, not the log of 7. So I can't just make this b squared. It's a different thing. I got to bring down those exponents before I can make that substitution.
Example 6.
All right. This question here says, if the log base 8 of x is 2/3 and the log base 2 of t is x, then determine the value of t. I actually really like this question. I like the connection of the ideas here. So if the log base 8 of x is 2/3 and the log base 2 of t is equal to x, okay, well notice that the connection here between these two is the variable x. So what I want to do here first is I want to convert this to the exponential form to get x out of the log. So the base here is 8, the logarithm is equal to 2/3, so 8 to the 2/3 is going to equal x. Okay? And right here I can evaluate this because I know that what this means here. This means the cube root of the base squared. So the cube root of 8 is 2, squared is 4. So I know that x is going to equal 4. Okay, so now I've got that clear. Now what I'll do is I'll take that 4. If I know that x is equal to 4, well, I'll rewrite that second logarithm there. So it'll become the log base 2 of t is equal to 4. Now, I'm being asked to figure out what t is, and it's trapped inside a logarithm. So what I'm going to do is I'll convert it to the exponential form to get it out. So the base here is 2. The logarithm is equal to the exponent, so this becomes 2 to the 4 is equal to t. And then it's just a matter of quickly evaluating. 2 to the 4 is 16. Therefore, t is equal to 16.
Example 7.
Okay. This next question is very similar to the last few that we've done here. Log base a of b is equal to 11.3 and log base a of c is equal to 3.3. Okay, so we're given some information here about a couple of logarithms. And then we're being asked to figure out the log base a of b over c squared to the nearest 10th. And there are a couple of different ways of doing this, depending on where you're at in this course right now. So I'll do them both ways here. Now, assuming at this point that you haven't done a lot of work with the log laws, okay, first thing that we might do here is convert this to the exponential form, basically to get information about b out of that. And so we'll know that a to the 11.3 is equal to b. Okay, and then we'll do the same thing with that second logarithm here, and we'll get a to the 3.3 is equal to c. So that's just us converting those two logarithms that we were given into exponential form. Now let's take a look at the other log that we've got here. We want to determine the value of log base a of b over c squared. Okay, well, the log base a of b over c squared. Well, what I can do now is I can replace b and c with the two exponential, the two powers that I just discovered there. So this will become the log base a of, well, b was a to the 11.3. And c was a to the 3.3 now, but remember that c was being squared, so I got to square that. So now what I've got here is I've got this set of brackets around the argument here. I'm going to evaluate or simplify what's inside there. So this is the log base a of, well, I can't do anything with the numerator, so it'll just be a to the 11.3 But I can do something with the denominator. That is going to be a to the, now remember I multiply those powers together, so it becomes 6.6. Okay, good. So I've simplified that denominator here. Now, to divide powers, I subtract exponents. This becomes log base A of A to the 11.3 minus 6.6. And well, that, whoops, sorry, gotta make sure you can see that. That is simply going to be the log base A of A to the 4.7. And at this point here, we see that if we've got a log base A of a power of A, they will just cancel each other out, and we're left with 4.7. That exponent becomes the value, as long as the base of the logarithm and the base of the power are the same. Now, that's one way of doing it. Okay, another way of doing it would be to take that log base A of B over C squared, and using our log laws, if you're familiar with them, to separate that out here. Now, division becomes subtraction. So log base A of B minus the log base A of C squared. Now remember, it's C being squared here. In the original question, I'm being given some information about the log base A of C, not C squared. So I need to move that, get rid of that 2. And I do that by bringing it out front. That's one of my log laws. This becomes minus 2 log base A of C. And now I can make the substitution. I know that the log base A of B, I was told in the original problem that this was 11.3. And I know that the log base A of C was 3.3. Multiply that out and subtract, and I get the same results. Doesn't really matter which way I approach it.
Example 8.
Okay, here's another question it's kind of easy to get lost in the question because there's a lot going on. It's a good question. There's a lot going on here. So what I suggest we do here is we just take this one bit at a time. Okay, the point 1/4 comma negative 2 is on the graph of the log function f of x is equal to the log base c of x. Okay, now before we do anything else here, let's just check and see what does that mean. Okay, well, the function that we're looking at here, f of x is equal to the log base c of x here. Well, we're being told that the point 1/4 comma negative 2 is on this function. So that means negative 2 is going to equal the log base c of 1/4. Okay, well, notice that, okay, there's this unknown c here, but I am given enough information to figure that out. Now, in a question like this, where there's more to this question, it kind of strikes me as that's probably what I'm being asked to do here, to figure out what c is. So convert this to the exponential form, and I get c to the negative 2, okay, because base and power, remember the base of the logarithm is the same as the base of the exponential function. The logarithm equals the exponent. This is supposed to equal 1/4. Well, c to the negative 2 means 1 over c squared is equal to 1 over 4. And just compare those two. The denominators are both 4. Well, what's the square root of 4? Well, it's 2. So c is going to equal 2. Okay. Now, I could do plus or minus 2, but I know it's going to be plus 2 because c is the base of the logarithm, so it's going to be positive. So now what I do, with that in mind, I'm going to keep looking at the rest of the problem. Well, it says here, the point 5 comma k, okay, is on the graph of the inverse of the given function. Okie dokie. So now I've got this function here, f of x is equal to the log base 2 of x. I know that because I just figured out what c is. Now the question is giving me a point on the inverse. So to get the inverse here, what I got to do is I got to flop the x and the y. So really, this becomes x is equal to the log base 2 of y. And then I'm going to convert this. I'll convert this to the exponential form to get a function in terms of x. So y will equal 2 to the power of x. So there's the inverse. And now I just got to go back here and it says the point 5 comma k is on that. Oh, okay. So here we go, 5 comma k. So k is equal to 2 to the 5. And that means k is equal to 32. And it turns out that's what the question was asking for. What was the value of k? That's a good question.
Example 9.
Okay, this question here says, convert the following logarithms to the base indicated. So here we start with log base 4 of 224. We're going to convert this to base 3. So all I'm going to do in this question here is I'm just going to go through the conversion rule here, okay? Maybe I'll put it in the middle here. And so it looks like this. The rule is the log base a of b is equal to the log base c of b over the log base c of a. As long as I take the same base logarithm of the argument over the base of the original, the ratio is the same. And so here, all I have to do to get this into base 3 is to take the log base 3 of the argument, 224, over the log base 3 of the former base, 4. That's all we're asking for here in this question. Don't want you to do anything else with it. Okay. So for this next one, convert the log of 612 to base 5. The only reason this question here is really just so that we can have this really quick discussion. If the base isn't written, what's the base? Well, it's 10. Okay? So then this becomes the log base 5 of the argument will be log base 5 of 612 divided by the log base 5 of the base that's not written, so we know that that's got to be 10. So log base 5 of 10. And that's what we want you to do in this question.